Before implementing a load balancer, let's talk briefly about the attributes of a target group. Here you can see all the attributes or settings that you can configure in the target group. If we click on Edit, we can see them more easily. So, the first attribute is the deregistration delay or draining interval. Deregistration is the process of removing a target, in this case a C2 instance, from a target group. This is the time that the load balancer will wait before deregistering a target. So, when a target is deregistered, the load balancer will wait these seconds to allow existing requests to complete and then complete the deregistration. I am going to set it to 5 seconds. The next attributes are the load balancing algorithms. By default, it is round robin, but also it can be configured as least outstanding requests and weighted random. With round robin, this method sends requests evenly and sequentially to all healthy servers. It is commonly used when the requests received are similar in complexity and the servers have similar processing capacity. With least outstanding requests option, it sends requests to the server that has the least number of tasks in progress. It is commonly used when the requests received vary in complexity or the servers vary in processing capacity. And weighted random. This method sends requests evenly and randomly to all healthy servers. For this demonstration, I will default to round robin. The next attribute is this slow start duration. Normally, when a target registers in a target group, it receives all requests immediately. Using this attribute gives the target time to warm up before the load balancer sends its full quota of requests. The next attribute is stickiness. By default, each incoming request is routed independently based on the load balancing algorithm. Stickiness allows the load balancer to bind the user session to a specific destination so that all user requests during the session are sent to the same destination. As you can imagine, this can be useful for servers that maintain state or session information. Then, in order to provide a continuous experience, you can use a cookie generated by the load balancer or by your application. You can also define a duration allows the load balancer to bind a user session to a specific destination duration during which all requests from the same user will be routed to the same destination. Next, we have an important attribute called cross-zone load balancing. I already talked about this in a past class. So, in this list, we have to enable or disable it. When cross-zone load balancing is disabled, each load balancer node distributes traffic only to the destinations registered in its availability zone. When enabled, each load balancer node distributes traffic to destinations in all registered availability zones. Think of a node as an instance of the load balancer in an availability zone. If you are not yet clear, let's understand it with an example. Let's say we have a load balancer assigned to 2 availability zones. Therefore, each availability zone will have a load balancer node. Let's say the availability zones have an unequal number of registered targets. Availability zone 1 has 2 targets while availability zone 2 has only 1. Now, let's see how the load balancer will handle incoming traffic when cross-zone load balancing is disabled. When disabled, the node will only forward to destinations in its availability zone. Then, when the first request arrives, the load balancer will forward it to the first node that is in availability zone 1. Then, the request is forwarded to instance A. When the second request arrives, the load balancer forwards it to the second node, which is in availability zone 2, and then the request is forwarded to the instance in that availability zone, which is instance C. When the third request arrives, it is forwarded to the first node, and then to instance B. When the fourth request arrives, it is forwarded to the second node, and then to the instance of that availability zone, which is instance C. At this point, instance C has served twice as much traffic as instances A and B, and this is because cross-zone load balancing is disabled, and also because we have an unequal number of instances in both availability zones. Now let's see the same scenario when cross-zone load balancing is enabled. Then, when the first request arrives, it is forwarded to node 1 of availability zone 1, and then to instance A. When the second request arrives, it is forwarded to Node 2 of Availability Zone 2, and then to Instance C. When the third request arrives, it is forwarded to Node 1, and then to Instance B. When the fourth request arrives, it is forwarded to Node 2, but Node 2 will now forward it to Instance A of Availability Zone 1. This is because cross-zone load balancing is enabled, so load balancing and the node will forward traffic to destinations in all registered availability zones. When the next request comes in, it is forwarded to Node 1 and then to Instance B. The next request is forwarded to Instance C and so on. As you can see, all instances are serving the same amount of traffic. Therefore, with cross-zone load balancing enabled, it is not necessary to maintain the same number of instances in all availability zones. For this reason, it is recommended to enable cross-zone load balancing. So, I'll leave this as it was, and let's look at the last attribute, which is the target group health requirements. These settings that you see here allow you to configure healthy state requirements, which in turn control when specific and healthy state actions are taken. There are two settings, DNS and routing. You can configure them together in unified configuration or individually in detailed configuration. In the DNS section, you can configure the minimum healthy target count or target percentage. If the number of healthy targets is less than this value, the availability zone will be marked as unhealthy. When this happens, DNS failover will occur and traffic will be directed to the healthy zones. Similarly, in the routing section, you can configure the minimum number of targets that must be healthy. If this value is not reached, the load balancer will send traffic to all targets, including the unhealthy ones. And yes, you heard right. If this minimum value of healthy or healthy targets is not reached, traffic will be forwarded to both healthy and unhealthy targets. This is known as fail open state. The idea here is that there could be targets that temporarily fail health checks, increasing the risk of overloading healthy targets. Therefore, if the minimum number of healthy targets is not reached, traffic is forwarded to unhealthy targets as well, increasing the chances of a successful client connection, thus reducing the risk of overloading healthy targets. So, I'll leave all this as it was. Save the changes. And with that, all that's left is to create a load balancer, and we'll do that in the next class.